Hello folks. Since our TA is sick and we couldn't have our regular Friday discussion section, I will use this video to talk about our PSA5, which is supposed to be the topic for today's discussion. So I will go over what you are supposed to do in this PSA, as well as how to test some of the codes that you write, because you don't have a tester for this PSA. So this PSA is due on Thursday by midnight, and what we'll do in fact here is we'll create several craters. So the topic for this PSA is we're going to create different craters, and they can fight, they can eat, and we'll put them into a simulator environment and see in the end who is going to win based on the behaviors of those craters. So the starter files, you have two starter files. First one is crater.java. What this file does is it's going to create a very abstract template for you to extend from it. In other words, we're going to create subclasses from crater class. And the three classes that you are supposed to create should be bear.java, lion.java, and tiger.java. There is really no order difference for those three different classes. You can create any of them first. It doesn't matter. The other Java file that you will have is called creator main.java. This is the major simulator codes that you use to create the simulator. You should not change any of them. Okay, so these two files should remain unchanged. What you should do is you should create three separate classes that extend from crater. When you compile your program, you should execute this command, javac, and then start.java. What start.java really indicates is I want to compile every Java file in the current folder. So you should put crater.java, creator main.java, as well as the three classes that you have created all into the same folder. And when you compile all of them, here are the things that you might see. Number one, you will probably see a few warnings. The warnings should be about that creator main, it uses some old API, which it does, but it shouldn't prevent you from compiling all the files. So they should be warnings instead of errors. And those warnings shouldn't affect how the simulator is run. The other thing that you probably will observe is you're going to see lots of class files once you begin to compile creator main.java. It is because in order for the simulator to run, a lot of classes have to be created in order to piece all those classes together to make the simulator work. And if everything goes well, you should be able to just run creator main and the following simulator should appear. Okay, so this is the interface that you should see. Make it smaller. So what you will see is you will see those different characters S, L, 2, 5, whatever they are, they represent different objects created from different classes. I think L stands for lion. And also there are stones and there are tigers. So if you look at them, they are basically those creatures are going to move inside the simulator once you create Go. And in the end, probably some groups of creators will win, because when different kinds of creators they meet, we provide a fight method to make them fight. So we'll discuss that later, but this is pretty much what you need to do for this PSA. Create three classes, and we kind of put some requirements about what each of those different classes should behave, and then we put them in the simulator and observe what's going on. Okay. The major part of this PSA is about creating those 3 classes: bear, lion, and tiger. So before we go into details of how to create those classes, one thing I want to stress is how to create your README. You should not use Microsoft products to create your README. You should create README using Vim. Okay. What we have observed is some of you used Microsoft Word to create readme.doc, for example, and then you just remove the .doc extension and you submit that file. What's going to happen is the file that you submitted will be encoded wrong, and it is not allowed. You should use Vim to create your README. Okay, and in here we have the regular program description and some questions about Vim and Linux, and also a question about Java. Style requirements are the same like before. Okay, let's look at the basic operation of the simulator. First, the simulator environment. Your creatures will exist in this 2D world, which has the origin on the upper left corner. Then the x-axis goes from left to right, the y-axis goes from top to bottom. So as you can see, the layout in here is very similar to how pixels are arranged in a picture. So your creatures are going to exist in this world. They can move in different directions, they can fight, they can mate, they can eat. So it's all described in the instruction. So one thing I do want to point out is as those creatures they move around, what's going to happen is the creature may go out of boundary in here. For example, if you look at this bear over here, right now where my cursor is, and then if it moves east again, it's going to be off the grid. So what's going to happen is the world will wrap it around. So if this bear moves to the east again, the bear will re-emerge from here, from the left side. So really nothing can go out of bound for this simulator world. But it is really not the big concern of us because everything is pretty much taken care of in creator main.java. Our job for this PSA is to create the classes such that creator main can call your classes to create the right creator. So let's look at individual actions that each of the creators can do. They can move. Okay, there are 4 directions that a creator can move, plus staying at its current location. So north, south, east, west, plus the current location. If you look at your creator.java, there is this enumeration direction, which is north, south, east, and west, and then center means just stay put, no change. Okay. All right. So this is the movement, and different creatures may have different ways to move. Fighting. Okay. We designed 3 different ways that a creature can fight: roar, pounce, and scratch. So this is how those 3 different fighting methods are gonna kind of pair against each other. If creator 2 roars, creator 1 also roar, then we're gonna use a random number generator to create a winner, 50-50%. Okay. But if creator 2 pounds, creator 1 roar, then creator 2 is gonna win. So this table basically kind of iterative list every possible scenario. One easier way for you to remember is roar begins with R, pounce begin with P, scratch begins with S, and the table basically follows the same rule as paper, scissors, rock. So roar stands for rock, pounce stands for paper, S stands for scissors. So this is how different fighting choices are gonna kind of be determined about who is gonna win. Okay, and then we have eating. Each creature have different eating habits. Basically, in the world, whenever there is a dot, if you look inside the world, at certain locations there are dots. When a creature moved into a position where it collides with the dot, the creature have to determine whether it wants to eat it or not. By the way, when two creatures they move into the same cell, then they will fight if they are of different species. If two creatures of the same type, for example, if two tigers moved into the same cell, which is possible, then they will mate. But for this PSA, we are not concerned about mating. We are more concerned about fighting. So this is the eating. So each creature again have different ways to eat. Okay. For scoring, basically the simulator will keep track of the score for us. There is nothing that we need to worry about in here. Basically, in the end, we want to know how many creatures are alive at the end, how much food they have eaten, and then how many other animals they have killed. Okay, a pretty cruel simulator. So for all the classes that you write, you should follow something like this. Public class, for example, bear, it should extend creator. And then you can put in any instance field that you think you need to make bear behave according to the requirements that we're going to discuss. So for the methods that you have to override for different creatures is number one, eat. The eat method doesn't need any parameter. It's going to return a boolean to indicate whether the creature will eat or not. So it's going to return true or false. Basically, creator main is going to call the eat method from your creator in order to get the return value from your creator and decide what's going to happen to that food. Should it disappear or should it stay? Because it depends on whether the creator object want to eat or not. Similarly, for fight method, it should take a string. Okay, if the opponent is lion, then the string probably is L. If the opponent is a bear, then probably the string is B, and it's gonna return an attack value. If you look at your creator.java, attack in fact is another enumeration. It's roar, pounce, scratch, and forfeit. What forfeit really does is I don't want to fight. So I think for all the three creators, we will have to let them choose either roar, pounce, or scratch. I don't think we ask them to forfeit their turn to fight. At least not in this PSA. Then we have get color. Each creature may have different colors. They may change their color based on the requirement. So get color will return the color of the creature object. So the simulator can display that object property in the simulator. Get move is gonna tell the simulator where this creature is gonna move in the next round. The last one is toString. The last one is toString. Basically, it's going to return the name of the creator. So when the simulator displays that creator object, it's going to basically use whatever the string return from toString as its display value. For example, if you look at it, you may have L. This is the return value of the toString for lion. Similar, B and T, right? T for tiger. So I think running the simulator is pretty straightforward. You just click around and there you go. So the three major classes that you should implement are bear, lion, and tiger. Again, they should extend from creator, and you can design any helper methods and any fields that you might need to make sure that each of those creatures, they behave as required. So all you need to do is to make sure that you clearly write the 5 methods that we discussed above here. So those are the 5 methods that each of those classes should have overridden from the creator. Okay, eat, fight, color, move, and toString. Okay, so here are some details. For the bear, a bear should have a constructor. Okay, and it takes a Boolean variable, basically tells if the bear is a grizzly bear or not. Okay, so this means your bear should have a field to indicate whether the bear is a grizzly bear or not. Okay, and also the color of the bear should be brown for a grizzly bear or white for a polar bear when grizzly is false. So you should know how to determine the color of your bear object, right? Eating behavior, bears like to eat, so always return true, a pretty simple method. Fighting behavior, always scratch. Again, bears are pretty interesting. They always do the same thing, right? Always eat, always scratch. Now, movement behavior. Bears, they move between south and east in a zigzag pattern. So south is basically going down, east is going right. So what they do is they'll first go south, then east, then south, then east. So this is how they move in the zigzag pattern. In other words, the getMove method should return the right direction whenever it is called. The toString method should return B. Okay. So this is the bear method. As you can see, in order for you to implement this move method, you might need some help from some of the instance fields that you create to help you to determine what is the right move for the bear. Okay. For the lion, it has a no arg constructor. The color of the lion is always red. Okay. Eating behavior. So the lion is gonna return true if it has been a fight since it has last eaten. In other words, the lion is kind of getting hungry after it fights. In other words, so if a lion has eaten and then it collides with another food, so should it eat that food or not? It all depends on whether it has been a fight since it has last eaten. Okay. So I think in here you should kind of think about what instance fields you might need to remember if a lion has been a fight or not. Feel free to design any of them that you might need. Okay. Fighting behavior, lions are smarter, so it depends on the opponent. Lions will kind of use different strategies. So if the opponent is a bear, it's gonna roar. Otherwise, it's gonna pounce. Okay. For the movement, the lion goes in kind of a square pattern. It is a clockwise square pattern. So it will go south 5 times, and then go west, and then go north, and then go east. So this is how lions move. Pretty much, they always move inside this weird square, right? They can never go out of it. Either they are killed or they fight, whatever. So this is how lions move. And then the toString, it just returns L. Okay. So lions is slightly harder than bears when you create the class. For the tiger, it has a hunger as an argument when you create the constructor. Okay. What that really does is hunger is an integer. It tells you. So for hunger, it is an integer, and what it really does is to kind of keep track of a count, because this hunger is related to the eating behavior. So we'll explain that in a second. The color of tigers are always yellow. Okay, As for the eating behavior, so this is where the hunger value comes in place. So it's always going to return true the first hunger times it is called. For example, if when I create a tiger, I pass a 5 in here. Basically, the eating behavior is for the 5 times that the eat method is called, is always going to return true. And then after that, it's going to return false. So basically, the tiger will eat for this number of times in the first place, whenever it gets a chance to eat. And then tiger will stop eating afterwards. Okay. For the fighting behavior, a tiger's temper is determined by whether it's hungry or not. Okay. So if eat method returns true, then it's going to scratch, or else it's going to pounce. Okay. So for the movement method, basically what the tiger does is first it's going to pick a random direction, okay, and then moves in that direction for 3 consecutive method calls to the move, and then pick another random direction and it repeats. So it's, for example, if it picks north in the first place, then it's going to move north 3 times, and then it will make a choice to say what is the next random direction that I will move. For example, if the next round it picks east, then it's going to go east 3 times, and this pattern just repeats. Okay. As for the 2 string, it is a little bit special. It is basically the number of pieces of food this tiger still wants to eat. Okay, so how do you decide that? So those are the 3 methods. Okay, I think for tiger, it involves some random values that you should generate. In PSA3 and 4, we have talked about how to generate random values. Okay, and you should use the next int method to generate the random values you need. Okay. All right. So testing. How do we test our code? So the first thing you can do to test your code is to run it in a simulator. So once you're done with the code, you can go to come here and Java C start.java. So it may take a while for you to compile the program, and then you see the warnings, which is okay. Then Java creator main. So the simulator should pop up, and then basically you can specify the parameters. You really don't need network features, but you can just leave them on. Okay, and then you click go, and things should move around. Okay. So right now we only implemented some of the methods, not all of them. So as you can see, we have tigers, we have lions, and in the end it seems like tigers are kind of winning. So it's gonna kind of stop, okay, sooner or later. Once things begin to collide, as you can see, we have lots of tigers and lions, okay, and the reason why we have lots of them is because they are kind of smarter. They are making decisions based on different scenarios. Okay, so we have bears, and obviously we can make even smarter creatures. Okay, that is what you need to do for PSA6. Okay, so I think we can stop here. There are lots of tigers, and there's just this line. It is kind of stuck over there, right? This is the pattern line, and it seems like the tigers are getting closer. Whatever, I think that line will be dead sooner or later. Anyways, so this is one way, but it kind of is interesting, but it really doesn't show you whether the methods that you have implemented are working or not, right? Because even if you have bugs, it doesn't kind of show it. What you really want to do is you can try to create your own tester file. So what that really means is you can create your own tester. So let's say test.java. Okay. So what you do is you begin to create public class test. You begin to create line objects and etc. in order for you to test them out. So let's see, public static void main. So what you're doing here is, for example, I want to test the tiger behavior. So I'll create a tiger equals new tiger, and I think tiger needs some sort of hunger value. All right. So what this hunger really means is I'll put in 5 in there. Okay. So right now, if I call, for example, if I want to call the eat method, I want to know whether my code works. So the behavior of your eat method should be in the first 5 times, because I have 5 in there. In the first 5 times that you call eat, it should always give you true, right? And then it's gonna supposed to give you false. Okay, so let's try it. I obviously have already implemented the tiger class. You can only test your program after you have finished those classes. So we can say for int I equals to 0, I is less than 5, I plus plus, and then you can print out or you can count. It really doesn't matter. I'll just print out. I'll let tiger call its eat method, and I want to observe what it gives back to me. All right. So I will say Java C start Java. So it's gonna create all the classes in there, and then I'll just run my tester. Java test, and as you can see, it gives me 5 truths, which is what it's supposed to do. So it seems like it's working. To be safe, what you can do is you can write another for loop. It doesn't matter how many times it runs, then you print out what's going to happen after you call it 4 times. I'll just compile test.java, and then I need to write it first. Alright. Java test, and it's supposed to give me a bunch of false. So this is kind of how you can test individual methods from the classes that you have written. Okay, so you can create your own tester. You call those methods because they are all public methods. So you can call them from an object and kind of determines what the value should be. And I would say probably the trickiest testing part would be the directions. Okay, so that's pretty much it. And there is a actual credit. We're gonna create a dragon, and it kind of does different things. The moving method is different. The attack modes are different. And I think our TA, before he gets really sick today, has created, this is the pattern. So for the dragon, it's gonna go this zigzag. I don't know the exact name of this shape. Maybe pyramid, maybe circular. And he made a small video in here that you can use to basically look at how a dragon is supposed to move. And this extra credit is 10 points. Okay, I think that's about it. Thank you and have fun with the PSA.